Hey, hello there. So gonna quickly talk about today's Leetcode challenge question. It's called first unique character in a string, and the question is as follows: given a string, we want to find the first non-repeating character in it and return its index. If there are no such character, meaning every character has at least more than one times, then we should return -1. So this question, I think it's sort of like a watered down version of 1429, first unique number, which is also our Leetcode challenge question for last month. So I do have my own video about it. If you're interested, you can check out the link there. I also put a spin on it to support pop, so the video is quite long. Yeah, it's kind of interesting if you want to consider pop, so definitely check out the video if you're interested in looking at that. So just let's go back to this question. If we look at the string Leetcode, we see that character L, T, C, O, D, they all appeared only once. E is the only character that appear more than once. So the question asks us to grab the very first one that with no repetition, so it's L, so the index is 0. So to solve this problem, we can just do one scan through the string to count up the number of times each character appeared in the string, and do a second round of check from left to right. For each of the letters we encounter, we check whether that letter has a frequency count of 1 or not. If it's 1, then the first one we find, from left to right, is going to be the one that we want to return its location. So that's 2 linear paths in the worst case, and the space is going to be the hash map, which stores the number of times each character appeared. So the size is equal to the vocabulary size. That's the total number of unique characters in a string. So it's actually quite optimal already. If we want to do even slightly better, we can utilize something like a ordered map, ordered dictionary, and potentially couple it with a set, or not. We can do that either. There are multiple solutions. We can use a set to do deduplication, or we can use the ordered dictionary with the values be a tuple of a number of times it appeared and the last locations we find it. And just keep moving that. Whenever we update that key value pair, we'll move it back to the linked list, end of the linked list, then we are fine. So there are multiple ways to improve the very first brute force solution to be strictly one pass. The necessity is not very high. So I'm just going to code up the hash map frequency count and do a second scan to find it first, and then code a set plus ordered dictionary solution. That solution is pretty much essential to the solution here. We have a set and a dictionary, but to support pop, it will be a little bit more difficult. So again, if you're interested, you can check out my video. Yeah, so just going to talk about this question, the simple, straightforward solution. We're going to create a hash map, store the character to its frequency count. Let's call char frequency, which is the just run a counter on the string, and then do a second scan from left to right. We want to grab the location as well. So if this character has the frequency count of exactly 1, we just return its location. If we don't return anything while this for loop, meaning from left to right, we tested every character, we still couldn't find 1 with the frequency count being 1, we return -1. So that's the code. Yeah, so in terms of the solution, this is definitely an easy level question. So a little bit improvement can be that we repurpose this hash map, use it to store the last location we see the character. and it has to be ordered. So the keys are sorted based on the time it's being inserted. So under the hood, it's a hash map plus a linked list kind of data structure hybrid in there. And we're going to use a set to do deduplication. So every time we see a character more than once, we make sure that we remove it from this hash map. So in the end, we can just check on the key values in here in the hash map. Those will be the characters with only one appearance in the string. And since it's ordered, we can just grab the very first one. It's guaranteed to be the first non-repeating character in the string. So there's just going to be an if-else branch based on whether we see this character or not. If it's the second time, at least there's a second time we see this character, we will make sure that it's never in the hash map anymore. So we pop it off, and else we will remember, yeah, this is the first time we see it, and we want to remember its location. So we can, after this just the one pass, we can do our return statement here. So if the hash map is empty, there is no character with exactly one time appearance, we can return negative 1, otherwise we'll grab the very first one. Yeah, so this is pretty much the code. It's linear in time, just one pass, strictly one pass through the string, and the space, it's proportional to the in the worst case, it's going to be 2 multiplied by the character size, the size of the vocabulary, because both scene and character location can take up to, if everything is unique, it's going to be 2 data structure each with number of unique character as the size. So let's submit this one as well. I do have an arrow, so next. I forgot a if statement. Let me run through an example. Yeah, so it works. So here you are, 2 solutions. One is 2 pass with strictly one data structure that's linear in size with the vocabulary size. The second one, the space can potentially double, but the time can potentially be half. So you got a trade-off there. So that's the question for today.